let's start chapter 6, and one of the things I want to let you know is chapter 6 is one of the most important chapters in your textbook because the strategies we learn here in chapter 6 will take us through the rest of the course. So what we've been doing in the previous 5 chapters is we have been putting tools in our toolbox, so we'll be able to use them when we want to make decisions. And the tools that we're going to learn in chapter 6 are some of the most powerful that we have in our statistics toolbox. And so we're going to be talking about those, and I recommend you do as much practice as you can absolutely fit in. So the chapter is going to focus on continuous random variables. Remember in chapter 5 we did discrete random variables where they were only had certain values. Well, in chapter 6 we're going to talk about those variables that have infinite number of values. And we're going to talk about normal distributions. And remember, a normal distribution is a bell-shaped symmetrical curve. Its peak is at the mean of the distribution, and the width of the curve is described by the standard deviation. Now, this curve is defined by a formula, and there's the formula. Now, don't faint. You're never going to be expected to put numbers into this formula, but I want to show you that if you remember from the last chapters, there is our z-score. Here is our standard deviation. It's got a curve in it, so there's a pi in it, but that's just the equation or the function that gives us this symmetric bell-shaped curve. This is going to be the last time you see this equation. You're never going to have to plug numbers in and do the math. So it's determined by the values of the mean and the standard deviation. And so let's talk more about the standard normal distribution. Again, the standard normal distribution is bell-shaped. The mean is equal to 0 and the standard deviation is equal to 1. So we would write that as it's a normal distribution with a mean of 0 and a standard deviation of 1. And so what we're going to do is we're going to develop the skills to find the areas, and the areas correspond to the probability. And that's why we did probabilities in chapter 4 and 5. And so we're going to find areas corresponding to regions under the graph, and then we're going to find z-scores that correspond to those areas. Now, to help us get started, let's talk about a uniform distribution. That means its values are spread evenly over the range of probability. The graph of a uniform distribution is always a rectangle. So what they're telling you is some value, let's say, let's talk about the time in a football game. The time in the first quarter, the second quarter, the third quarter, and the fourth quarter are all the same. So we know the whole game is distributed in there, and if we want to know, what part of the game is, what proportion of the game comes before halftime, we can do the math. We can calculate this area, which is going to be length times height, and guess what? Because it's the first half of the game, that area will be 1/2. So that's what a density curve is. The things about a density curve is that the total area under the curve must equal 1. When we're talking about probabilities, that's 100%. Every point on the curve must have a vertical height that is 0 or greater. So in other words, the curve can't fall below the x-axis. So all the numbers are on the vertical scale are always positive. Since the area is equal to 1, that corresponds to 100%. That is, something in that distribution is going to happen. That's the probability. Remember, the probability that something is going to happen is 1. The sum of all the possible outcomes add up to 1. And so we're going to look at how area is linked to probability. If a satellite is going to crash at a random point on the Earth, what's the probability that it will crash on land? Well, let's think about the Earth, and this is Peter's projection. Whenever you see a flat map, it becomes a little problematic because the Earth isn't flat, but this will give us just an idea to think about and to envision. So here's our map, and there's over 54 million square miles of land and over 142 million square miles of water. So what's the probability that the satellite's going to crash on land? Well, it's going to be the area of the land divided by the total area of the Earth, and it comes out to be 0.275. So that means the probability that our satellite's going to crash on land is about 27.5%. Now we can also say the probability that our satellite will crash in the ocean is going to be about 73%. Let's look at this. And this is a uniform distribution that deals with voltages. And what happens is the area under this curve is 1. Well, it goes from 123 volts to 125 volts, which is a difference of 2 volts. So the height of our curve has to be 0.5 because 2 times 0.5 equals 1. But now it says find the probability that a random variable will be greater than 124.5 volts. So that's why we're looking at this area here that's above 124.5 volts. So we can see that this difference is 0.5. We can see that the height of our rectangle is also 0.5. So 0.5 times 0.5 is 0.25. So the probability that our voltage will be between, will be greater than 124.5 volts in this scenario is going to be 0.25 or 25% of the time. When we have a standard, okay, let's just cut this off a little bit. A normal distribution means that it's bell-shaped, the mean is in the middle, and its width is described by the standard deviation. Now when we talk about the standard normal curve, by adding that word standard, what we do is we put a few more limitations on it. In the standard normal distribution, the mean is 0 and the standard deviation is 1. And we use z-scores with a standard normal curve. Okay, and remember from one of our previous chapters, z equals my score minus the mean divided by the standard deviation. And so we can find the areas for different regions using table A2 in your textbook, or we can use StatCrunch. Now there are some very good videos on this page that talk about using StatCrunch and the tables, but what I want to do is I want to pull up the tables so we can kind of go through this. Now when we look at our tables, our z-score tables, and they are in the back of your book in the appendix, You can also find them in that barrel fold tables in your ebook. You can also find the z-scores. Now I have a hardcover book, so I have the z-score tables in the end pages in the back of my book. I believe in the soft cover book they're also in the back end pages back there. So that's a place we can find A2, or A2 is on page 684 and 685. You can see those physical tables, and that's all we had until computers became widely used, and now we have software that helps us out, and we're going to be doing most of this in StatCrunch. But what happens in our tables is they give us the area to the left of our score. So I'm just going to pull this over so you can see it. And so here are our z-scores, and so if we have a negative 2.45 z-score, we are going to write on this 2.45. We're going to go on this negative 2.4. We're going to go across here till we get to the 0.5, and there would be our area to the left of that z-score. So that's a quick way to do that, and we will be looking at that a little later. And then how do we do it on StatCrunch? And again, this instruction box is on page 249 in your book. You may want to flag that to make your next test a little easier. So again, here is the table. These little stars we'll talk about at another time. The table A2 has two pages. One is negative, one side's negative and one side's positive. We've looked at the negative side here. Okay, so again, the mean is 0, the standard deviation is 1. One page is for negative z-scores, the other page is for positive, and all of them look at the cumulative area from the left. And remember, when we are looking at the z-score, we are looking at the distance along the horizontal scale. The area is in the body of the table. So here's an example. And so we have a company that makes thermometers, and they are supposed to give readings of 0 degrees Celsius at freezing, and they've also found that the standard deviation of the readings is 1. So if one thermometer is randomly selected, find the probability that the freezing point of water, at the freezing point of water, the reading is less than 1.27 degrees. Now, this is easy because our mean is 0 and our standard deviation is 1. That's the same as a standard normal curve. So here we go, and we're going to look at our table, and remember, positive z-scores are to the right of our mean of 0. Negative z-scores are to the left. So now let's look at table A2. This time we're going to look at the positive side, and our z-score is 1.27, so we follow the 1.2 line over till we get to the 0.07 column, and we see that's 0.898. So that's why we say this area in light blue is 0.898. That also tells us 0.898 of the area of 1 is less than 1.27. So let's think about it some more, and we can interpret that as the probability of randomly selecting a thermometer with a reading less than 1.27 degrees is 0.898, or 89.8% of the readings will have a reading below 1.27. I like to change probabilities to percents because it makes sense in my mind, but many people recommend you think about them as decimals, so you don't get them mixed up when we're dealing with percents, when we're dealing with proportions. You have to see how your brain wraps around that. We've got the same scenario, but this time we want to know what's the probability that the thermometer at the freezing point of water will read above a negative 1.23 degrees. So now our z-score is a negative 1.23. Let's go back to the table and let's look at the table A2, and we want a negative 1.23, a negative 1.23 right here, 0.1093. This is what we found on the table right here. But we want to know the area above it. So we don't want to know the number we read off the table. We want to read it. We want the area to the right. So since we know the area under the curve is 1, we're going to subtract our table number to get our probability because we're doing a greater than. And so the probability of selecting a random thermometer with a reading of a negative 1.3 again is about 89%. Okay, let's keep going with the table. And so 89.07% of the thermometers at the freezing point of water will have readings above a negative 1.23 degrees. I also find it nice to put things in sentences because then it helps those numbers have meaning in my head. Now sometimes we want to do in-betweens. So we want to find the probability that the thermometer reads between a negative 2 and a positive 1.5 degrees when it is at the freezing point of water. So what we need to do is, I call these betweeners. Okay, so we want to think about it. What's the area below a negative 2? And we can find that from the table. And that's this little tail right here. And what's the area below a positive 1.5? And we'd find that from the table. Well, if I want to know between there, I'm going to take the area that's lower than 1.5 and I'm just going to snip off the tail that's below the negative 2. And so that's why we're going to do this math. And we get the area between is 0.9104. Let's keep going with the tables and then we'll go back and do all of these with StatCrunch. If many thermometers are selected, then about 91% of them will read between a negative 2 and a positive 1.5 degrees. This is our notation. Probability that the z-score is between A and B, the probability that our z-score is above A, and our probability that our z-score is below A. We can find the z-score when we're given a probability. We are going to draw a picture. That's always a good idea. Decide if we're to the right or to the left. So let's look at a number. Remember, the areas are in the body of the table. So if we want to find the 95th percentile, then we know 95% of the scores are below that. So what we're going to do is we're going to go to the table, but I need to have the positive. And let's just go back to the picture. Notice our 95% is to the left. That's how the table works. So I'm going to go to the next page, to my positive page, and I'm going to search in the body of the table for the number that's closest to 0.95. And can you see it's right here? Okay, what does that mean? That means that this is 5/10,000ths too low. This is 5/10,000ths too high. So guess what? The number is right in between there. So we would add these together and divide by 2. And so our z-score is going to be 1.6, and halfway between there will be 4.5. Let's look at the next slide. So we found it on the table. Our z-score was 1.645. We want to find the bottom 2.5% and the top 2.5%. So one score will be negative and the other will be positive. Since our area to the left is down here, I'm going to focus on the negative z-score. So let's bring our table over, go back to the negative side, and I'm looking for 0.025. Aha! Right there. So what's my z-score? It's a negative 1.96. I know this is a negative 1.96 because I want the top 2.5%. A couple things that I know. Because my middle is at 0, you can think of it as folding this in half. And if this is 1.96 standard deviation units, which is what a z-score is, below, this one's going to be 1.96 standard deviation units. Our answer would be positive and negative 1.96. Let's go back and let's use StatCrunch to do these same problems. So let's bring in StatCrunch. Okay, so we're doing the what's the probability that z is less than 1.27. So what I'm going to do is I'm going to refer to page 249 and I'm going to click Stat, and I'm going to go to Calculators, and then I'm going to go down to Normal, and let me pull this over so you can see it. It's going to open up into a standard normal curve where the mean is 0 and the standard deviation of 1. I want this to be less than, and don't worry, you only have the choice of less than or equal, greater than or equal to. That's okay. But I'm going to put 1.27 in here. I'm going to do compute, and there it is, 0.9554. Why is that not right? Because I didn't type it in right. It's 1.27. Now I'm going to compute, and there we get 0.898, the same as we had on our slide. Let's go to the next slide. Now we want to know, what about a z-score greater than a negative 1.23? So I'm going to just flip this to greater than a negative 1.23, and I'm going to do compute, and there we go. I get 89.06 da 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 da. Now, your work with this calculator on StatCrunch will be more accurate than the work with the table, because the table can only be rounded. I mean, it's rounded to 4 digits, and we only have 2 places in our z-score. So just remember that. And the other thing is because we can switch this, we're not stuck with reading only to the left. We can read to the left and to the right depending on what we need. Now let's look at the our betweener. So I'm going to click on between, and again my mean is still 0 and my standard deviation is still 1. And now on my small end I want a negative 2, and on the high end I want 1.5. So by doing this here, I get the same answer as I got on the slide, 0.9104, but I didn't have to think about, oh my gosh, this is to the left, that's to the right. What am I going to subtract from what? When you use StatCrunch, it does it for you. But it's the same idea that from here to the left was one value, and we had to take off the little tail that was below the 2 to get to our appropriate area or probability. Now, when we want to find the probability and we need to find the z-score, we'll go back to the standard, but let's say we want to say, I want to know what score is the upper cutoff for, and that's when we're going to delete some things, the 95th percentile. So what score has 95% of the area under the normal curve below it? And there we go, 1.64, and that rounds to 1.645, just like we found with the table. The nice thing about doing it with my stat lab is I'm a bad table reader, and sometimes you miss your line, and you know, when you reach a certain age, it's a little hard to read those little bitty tables, but you can see it here on my stat lab. So what did we do in this section? We've looked at density curves. We've looked at, and that's both uniform, which is a rectangle, and the standard normal curve. We've looked at the relationship between area and probability. We've looked at the standard normal distribution. We've used table A2, and we've used StatCrunch. So take some time to practice this, and I would do as many problems as you absolutely can fit in.